solving power and root equations. And that's identical to our objective. We want to solve power and root equations. Go figure, huh? So let's talk about what we know coming into this that's going to be useful. We know what a power function is. Any function of the form y equals a coefficient times x to the exponent, where the coefficient and the exponent are real numbers and the exponent is not equal to 0. Again, as a reminder, your power functions have an exponent, but the base is the variable. The exponent is a real number. And a root function is any function of the form, and we kind of are focusing here. Y is equal to a coefficient times the nth root of x, where a is a real number, and n is an integer that is equal to or greater than 2. Square root, cube root, fourth root, etc. The key thing to know, as you probably have figured out, power functions and root functions are inverse functions. Inverse functions are functions that undo one another. Okay, so we want to solve power functions algebraically. We'll use the root function to do that. And if we want to solve root functions algebraically, we'll use the power function to do that. And then we're also, of course, going to solve these graphically. As a note, if the root is even, there are always two results. Okay, the square root, you always have two results. One is positive and one is negative. And we'll take a look at an example of that. But if you have an even root and if you have an even, is it a power? If the root is even, I mean to say here, if the power is even. Sorry about that. If the power is even, it's squared, fourth power, sixth power, etc. When you take the root, you always have two results. In addition, always check your solutions. You may have extraneous solutions or incorrect solutions, so always check your solutions. Okay, let's take a look at some examples. Solve the equation. We're going to do these algebraically as well as graphically. Solve the equation 540 equals 5x cubed. Okay, I'm going to jot it down here. 540 equals 5x cubed. And this is a power function. I need to solve it with the root function. But before I do that, I need to get this 5 out of the way. So I'll divide both sides by 5. And I have x cubed, because 5 divided by 5 is 1. And 540 divided by 5 is 108. So now I'm ready to use the inverse function. This is the cube. I need to use the cube root to both sides. So I'll cube root the left, and I'll cube root the right, and I'll come out with x is approximately equal to, I went to the hundredth here, 4.76. I just cube rooted 108 there. Okay, let's solve it graphically. This is the algebraic solution. Let's go graphically. And we know graphically, y equals 540, y equals the left side, and y equals the right side, which is 5x cubed. And this is a power function. And we're looking for the intersection. Where do they cross? We're hoping they cross at 4.76 approximately, but we're looking for the intersection. So let's go to Desmos. Let's go to our graph here. Give me just a moment to get it together. Okay, we're in Desmos. All right, we have a y equals the left side. So y is equal to 540. And that, of course, is just a line. So if I need to go up to 540 on my y-axis to see it. And there it is. In my case, it's purple. And this is where y is equal to 540. Now I need to put my power function in there, the right side. Y is equal to 5x cubed, 5x, a to the b cubed. And there's my cube function. Okay, so I'm going to come into here. Okay, so you can see the cube function in my case is in black. Comes from down below and goes up. And the question, of course, is where they intersect. Well, they intersect right there. And there you go. They intersect when x is equal to 4.762, Desmos tells me. I just rounded to the 100th, 4.76. So there you have it, solving that first one both algebraically using the inverse function and graphically. Let's do some more examples here. Give me a second so that I can I need to find my paper. So just a second here. Here it is. Okay, I had to locate, sorry about that. Let's get myself together. Okay, I think I'm together. Thank you for your patience. Okay, we're going to solve this equation. 4 times 2x minus 3 to the 4th power equals 2,500. Notice we have an even power, 4th power. That should click in our heads. Even power. When I go to take the root, I'm going to have 2 solutions. So let's do it algebraically. 4 times 2x minus 3 to the 4th power equals 2,500. Let's divide both sides by 4. I want to get this by itself, so I'll divide both sides by 4. That's a 1, so I got the 4 moved over. And I have 2x minus 3, all of that to the 4th power, and 2,500 divided by 4 is 625. Now, I need to undo the power. I will take the 4th root of both sides. Now notice, I'm taking an even root. I have an even power. I'm taking an even root. So, there are 2 results. Well, it undid this one. So on the left, I have 2x minus 3. And then I have plus or minus. Plus or minus. The 4th root is 625. Plus or minus 5. Okay, even power, even root. You have to recognize there are 2 possibilities. Okay, 2 possibilities. Because positive 5 to the 4th power is 625. And negative 5 to the 4th power is also 625. So even powers, even roots, 2 possibilities. So 2x minus 3 is equal to positive 5, or 2x minus 3 is equal to negative 5. Add 3 to both sides. 2x is equal to 8. Divide both sides by 2. X is equal to 4. That's one answer. Add 3 to both sides. Well, same thing. Add 3 to both sides. 2x is equal to negative 2. Negative 5 plus 3 is negative 2. Divide both sides by 2. X is equal to negative 1. So I have 2 answers, positive 4 and negative 1. Okay, let's check it graphically. So graphically, okay, we'll have y equals the left, which is 4 times 2x minus 3 to the 4th power. And we'll have y equals the right side. And as usual, where do they intersect? And we're hoping they intersect in 2 places, positive 4 and negative 1. Let's go. Okay, come up here. Get myself up there. There we go. I think I'm straight. I'm never ever sure. Okay, left side. Y equals, parenthesis, 2x minus 3, close parenthesis and square it. Excuse me, not square it, 4th power it. I gotta choose the A to the B key so I can put a 4th power in there, put a 4th in there. I chose a square. Sorry about that. And there's the first side. I probably can come in a little bit here. Let's find out. And I gotta go higher actually. And then the second, the right side is y equals 2,500. I gotta go much higher on my y-axis. Y equals 2,500. Well, that's way the heck up there. Okay, this is 100. I gotta go to 2,500. So come on down, come on down. There it is. It's the blue line here. And so you can see this is the y equals 2x minus 3 to the fourth power. This is y equals 2500. They intersect in two places. We're hoping one of them is going to be, I forgot the 4. Whoops, let's go back into here. I forgot to put a 4 in front. Glad I caught that. Let me put a 4 in front. There we go. I'm sorry about that. You probably caught that back where you're watching this. There needs to be a 4 in front of there on the left side. Now I've got it. Let's touch here. And there's my -1 answer that I got algebraically. And let's touch over here. And there's my x equals 4 answer that I also got algebraically. Okay, so we have solved power functions using root functions algebraically to solve them. Now let's solve root functions by using power functions. Example 3. Give me a sec to get my paper together. 3 times the cube root of x is 12. Solve for x algebraically. Well, I have 3 times the cube root of x is equal to 12. Let's divide both sides by 3 to get the 3 out of the way of my cube. That's a 1. And I have the cube root of x is equal to 4. Okay, how do I undo a cube root? I use cubing. If the root is a third root, I raise to the third power to undo it. So I'll raise both sides to the third power. And this undoes that. And I have x equals, 4 to the third power is 64. Okay, so I think the answer is 64. I can check it algebraically. Well, let's do it graphically. So graphically, y equals the left side, and this time let's not forget any of the numbers like I just did in the last problem. So we have the cube root of x, and have y equal the right side, in this case y equals 12. And as always, where do they intersect? What is the intersection of those two? This one's going to be a curve, that one's going to be a line. Okay, let's go back to Desmos. Back to our graph. Get up in there. Let's delete these two. And let's see if I can do this without forgetting any numbers. Let's see here. The left side is y equals to 3 times. It's a cube root, so I got to go under functions and find my variable root button. Key is this one right here. And I'll put a 3 in the index right there. And then I have the x underneath. And that's the left side. And I probably can kind of come into here, and there we go. That's a little better. I kind of zoomed in a little bit. So that's y equals 3 times the cube root of x. The right side is 12. So how about we'll put in y equals 12. And that's up here, so I got to come this way a little bit. And it looks like this is getting there, but it's getting there slowly. So I'm going to have to kind of pull my x in a little bit. You can see I'm getting closer and closer here. And where do they intersect? Oh, they intersect right there. Where is that point? I'll touch it. And sure enough, when x is 64, which is what I got when I solved it algebraically. When x is 64, you get 12 for y, which is what I have. All right, last one. Solve the equation, whoops, make the paper up there for you. Solve the equation 5 times the 4th root of x equals -15. Okay, 5 times the 4th root of x equals -15. Well, I need to get the x out under the 4th root, so I'm going to take the 4th power, but I need to get this 5 out of the way first. So I'll divide both sides by 5. That, of course, is a 1. And on the left side, I'm left with the 4th root of x is equal to, well, -15 divided by 5 is -3. So now I can apply the inverse operation. This is the 4th root. The inverse of 4th root is 4th power. That'll undo the 4th root. So 4th power both sides. And that's probably not even a correct phrase, but you know what I mean. I'm raising both sides to the 4th power. That's better mathematical language. And I have x as -3 to the 4th power is +81. Okay, we've already done an example of how this looks graphically, so I'll let you do that if you'd like to, but you'll find that the intersection does indeed occur when x is equal to 81. So there you have it. How do you solve power and root equations? You do them by using the inverse. If it's a power equation, use the root. If it's a root equation, use the power.